Cool. 1039, minimum score triangulation of polygon. Given n, consider convex n-side polygon, vertices labeled a sub 0 all the way to a sub n minus 1 in counterclockwise. Suppose you triangulate the polygon in n minus triangles. When you triangle, the value of that triangle is the product of the labels of the vertices, and the total score of the triangulation is the sum of all these values over n minus 2 triangles in the triangulation. Return the smallest possible total score that you can achieve with some triangulation of the polygon. Cool. This is actually, what is this example? 3745, 3745, okay. Cool. What is this one? 1, 3, 1. Okay. Wish I had a whiteboard. But I would say, so I think we talked about this yesterday, actually. I don't know if y'all on the stream, but so the number of triangulations in a polygon is related to, again, Caroline's number, which is why I know it by name, because it comes up actually a lot. And this is also related to kind of what we did yesterday. You know, I had a lot of issues. I think actually, I think you were the one who brought up that problem, the one with, was it popping balloons? Yeah, so, which is related to, you know, number of ways to parentheses, right? Something like that. Parentheses and operator statement or something. There's a better way to phrase it. But essentially, it is the same. So I do recognize this problem as having the same. You know, that's the kind of. Yeah, that's how you would kind of go about it. And in that way, my first inclination is that it's very similar to what we did yesterday. And it's good because I actually struggled a lot with it yesterday. So hopefully this is maybe a way to redeem myself. We'll use C++ for that reason, though, so that I kind of, I like doing DP in C++, but yeah. So hopefully, you know, maybe, but the thing's a little weird. But that's my inclination. But let me think about this a little bit more. I think there's some stuff about loops that I may have to be careful about. But basically, the idea is that you draw a vertex from another vertex, and it divides the entire thing into you know, like let's say you have, what's this? So this is a hexagon. So you have a hexagon. You could draw a line from a line from one vertex to another vertex that isn't already connected to, like is adjacent vertex, and then you kind of do divide and conquer that way. I think that's how I would maybe think about it. But let's kind of see how to actually code it, though, because there's a lot of not weird, just you have to kind of define the problem very precisely. Okay, let's see. So there are two triangulations, 275. Oh, sorry, 375, and that's, well, okay. Okay. I mean, a lot of it is just kind of, at least for me right now, is just trying to figure out what is a good way to represent this, and like, what does it mean to draw from a number from 7 to 5? That means 4 is the vertex that is. I mean, kind of similar like to popping balloons. Then it's just that 4 is the vertex that is being popped, if you will. I mean, in that. Hmm. Hmm. So what does so once you pop the 4, you don't care about the 5 and 7. I think that's okay. So let's say you choose 5 as one of the vertex, and what does it mean to divide a number? It is 4. Yeah, I think the divide and conquer thing is in there somewhere. I think trying to figure out how to represent the how to represent that and structure it is kind of tricky. Obviously, this is a medium. Oh man. Um, so it's 4, 5, 7 plus 3, 7, 5. I think one thing I should this is just too much visualization, so I'm gonna get out a pen and paper for a second. Sorry if I'm like a little off stream. I actually usually don't need to, but for this one, I think I would benefit a little bit from doing that. So give me a second. Or I'm just going to draw out example 3. So you have 1, 3, 1, 4, 1, 5. So the minimum square is 1, 1, 3, 1, 1, 4, 1, 5, and 1, 1, 1. I think I drew this well. Maybe I did draw this well. How do you get the 1, 1, 1? Maybe just the ones. Okay, fine. I get it. I just drew it differently. Okay, I have 2 1 1 4s instead. Okay. Yeah, wow. So what does it mean to draw a line between the things? Well, if you draw a line between two numbers, then you have I think I'm okay, maybe. I think I just have to be careful about handling it. So you cannot draw a line from... Yeah, I think I'm just going to try to brute force it a little bit. I think you just have to... yeah, you have to figure out... You pick a vertex. Is that an n square? Because they're... Let's see, you want to count all of them, right? and this vertex could be in a number of places. So yeah, so the number of decision on a vertex is that other than hitting up the adjacent nodes, it's either this is part of the final triangle, or there's an edge from this node to one of the other edges that are not in the adjacent one. So I think those are the two cases, and then you could subdivide the polygon that way. Hand waving a little bit, but I think that's maybe roughly right. All right, I'm going to try to do that and play around with it. I know I'm not articulating that part very well, but that's kind of, I think I have it in my head a little bit. But I said that last time, so we'll see. And I think it's just kind of mapping the cross functions and stuff like that. But yeah. And these wraps around, so okay. Yeah, this is a medium though. Maybe there's some cool way of doing it. Don't tell me yet though. The constraint's 100, so that's like 100 squared. Well, sorry, 100 cube times. That's only a million, so maybe I have to do a billion should be okay. Right? Yeah, seriously. I appreciate that. Though maybe I could use a little more confidence booster before, but that's fine. I think there's actually another way to do it, or think about it, that I didn't do, but I think it's just taking, yeah, at each knob, you lop off one of these, you lop off one triangle, which, so that is the cost. And then you create a new triangle from the adjacent, but then you have to represent the left and the right in a weird way. Yeah. I think there is a cute way to do it, maybe. Let's say you lop off I. What does that mean? That means now you. Oh, sorry. Well, I guess it doesn't matter if it's the first lop off, the last lop off. But let's say this vertex I is the last number standing in a triangle. Man, Yeah, cos. I'm also thinking about maybe like doubling the size of the array so we could do like some loopy loop thing, or triple maybe even, I don't know, but yeah, even when you feel like, that's the tough part about dynamic programming, is even if you feel like you know like the general form of it, you still have to figure out all these like little little tricks thing about it. Okay, well, let's just get this out of the way. The base case, I think, maybe not, maybe I should do this later. What does that mean? Okay, let's say I put this here, right? Let's have a vertex on the left. Well, let's say left, right, and we're trying to find one point to draw left and right to. Okay, maybe that's a better way of representing it. So now we have, so in this case, we have, well, not that case, but we have 3 and 5, and then we try to find the best line to draw that contains best line from 3 and 5 to draw. So then you loop from 4 and 7. Okay. And that forms, is that always from a triangle? Yeah. Right? Yeah. Because your left and the right, because it wraps around, will always be adjacent side. So you're just creating a triangle between these two boundaries and one other vertex, and then you subdivide it that way, and then your new left and right will be the new thing for. Okay, I think I got it. Maybe. Yeah. It is definitely not easy, and also, why are my bounds always so silly? Um, okay, so this is me creating a triangle. Triangle, I can't even spell anymore. Between left, right, and I. Okay, so what does that mean? That means the cost is now, it's going to be, oh, I didn't copy it away. Okay. It's equal to a sub left times a sub right times I. Okay. That's the cost of drawing this triangle. And then now you have, yeah, and yeah. And then it's this plus get min, oops, left to I plus cost of I to right. Yeah. Oh, I didn't set them in. Oh man. Oh, I don't have a base case. Does that even matter? Should that matter? Oh yeah, I mean, I need to at least, if we only have 2 points left, then return 0. Maybe that's not the right base case, but let's kind of see. Cross. Oh man, I'm just being dumb today. Yeah. You should be trivially right for this one. Okay, well, it's close, but I've also so many silly mistakes. I mean, that's the so this should be right only because that's essentially the base case, but this is the real test. Also, I mean, okay. Hopefully I did learn something yesterday. Oh man, I should have just test some base cases, but, or like edge cases. Okay, cool. I think I hand waved it a little bit, so please ask me questions as you kind of see them. I'm going to try to explain it a little bit as best as I can. I mean, though I'm sure the discussion board's a little good about it as well. But yeah, my observation was, I mean, for a long time, I think I was thinking along the lines of kind of like chopping off a vertex or something. And there's certainly ways to do it, but it was kind of, there's always, I mean, the thing I was struggling with was that there's always some weird, I didn't like this. There's always some weird, so I took 28 minutes, which I guess is okay. But I'm probably a little slow given that I kind of have like almost like not a hint, but like know what the shape should be look like. But I think with dynamic programming, that's the thing is that you have to really figure out how to formulate these problems. And the thing that I was trying to formulate stuff around, even though I knew there was a regression, is that what does it mean to have, you know, like what do these represent? And for me, I even though I think this is kind of like the form I want, I didn't know what they represent for a long time. And I was trying to figure out like, well, maybe it means that we took a vertex and then we moved that vertex with is to adjacents, and then kind of like subdivide that way, like almost like actually in triangulation, there's a thing called I think year clipping algorithm or something like that. Some people even make references to Rango, but but so there are a lot of studies on triangulations and stuff like that, though. I don't think any of that helps you here, other than maybe knowing that there are n-2 triangles in a triangulation, and in some weird way, it's related to counter numbers. So that also gives you a sense of like how many possible combinations there are to create different triangulations, which is what led me to this form, because the way we do this form is very it's structurally very similar to how you calculate counter numbers. So that's kind of how I was thinking about it. And I know how, you know, a lot of this is hand wavy just because that's I think for me a lot of this is like intuition, and I'm trying to figure out how to articulate the intuition, and a lot of it is just experience, and a lot of experience is just me like learning about a lot of these over a long time, and it's not meant to be a brag. It's just, I mean, but you know, if you hear how I describe it, that's kind of how I, stepwise think about this problem. Um, but yeah, I struggle to kind of take off the vertex. I'm sure like smarter people more trained. That's why they like the problem. And also, it should probably be a hard, to be honest. It should not be a medium, though. I think. I mean, as I talk about this meta a little bit, is that the higher number ones, which means the newer problems, because they do these like contests nowadays. I think the mediums are getting way harder because like they need people to differentiate, because otherwise everyone solves everything in like 10 minutes and you can't really win a contest that way. But anyway, that's another story. But I was struggling to kind of yeah, given um, yeah, given a vertex, how to kind of chop it off so that like we could kind of have that structure of like um, divide and conquer structure, right? But I think at some point I just realized like if you look at this as in fact um, an edge on the border of the polygon, and then from there you only need another vertex to draw a triangle, and the cost of drawing that triangle is given to you by the product of those the weights of the three vertices. Um, and then if, I'm not really showing you this visualization very well, but I don't know if you could see me white drawing stuff. Not really. Okay, never mind. But you can imagine that uh, now that there's a polygon and there's a triangle in the middle, now you can think of it as like two separate polygons, one to the left and one to the right, and that's how I did the recursion there. And at this point, because your triangle divides your polygon into three parts, right? One is the triangle that you just created, which we calculate the cost for, and then one on the left, which um, which is which means that the edge that was on the triangle that you just created, that edge is also on the border now. So then that's how you get like one of this, and the same thing for the right side, using that other vertex. And as a result, and then you can kind of recurse it on that way, not caring about the rest of it. That's how I kind of think about it. But yeah, I love I mean, I know I'm doing very hand wavy stuff. At some point I need to get one of those cool like iPads with like hook it up and just draw it for you, because it'll be way easier. I should really set it up. I actually do have a mini iPad somewhere, but I just haven't set it up yet, or at least not for that. But that's how I would think about it. Yeah, yeah. I mean, I'll do. Yeah, I'll definitely actually go to the discussion and look at their solutions. I just want to go over a little bit about interviewee stuff. Definitely, this is. I mean, this is a medium, like as I said, or they've graded as a medium, and maybe it's medium on a like a competition programming thing, but it probably is not a medium on like what I was gonna say, like an interview, right? This is probably a little bit on the hard side. I don't know. I don't think I would expect to see this on a interview. I mean, it took me a little bit of time. I mean, granted, I'm not super fast as some of these crazy good people are, but as I kind of like point out, I did have a lot of like I had not hints, but like just like shades of my past guiding me along the way, and still it took me like 25 minutes. So I can imagine like some of this, like you see triangulation, and there's stuff that I take for granted that I may not even explain necessarily very well, that like people just struggle with because they've never dealt with computational geometry before or something like that, right? So that's not a fair. I mean, and there are other ways to represent this problem. I think this is also very similar to yeah. So I think you could. I mean, this code is actually exactly the same as yeah, maybe not. Maybe just like an off by one boundary, something like that. But this recursion is the same ish, and maybe a different base case as the balloon popping, which I believe is also related to what you call it, matrix multiplication. and it's very similar to like you could there's some like base case stuff that you have to mess around with, but it probably reduced to a variation of the matrix multiplication thing where you're just multiplying an array, a matrix of size left and a sub left and a sub right, and or like that's your final matrix, and then you have all these things in between, right? I'm hand waving a little bit there. I don't want to get that much into it because that's just unless maybe it's fun to have an interview. You have a lot of time left, and you can talk about all these cool things and nerd out and geek out. Not sure if that's typical, but I think but if I want to ask like matrix multiplication related things, that's what I would ask, and that at least like it's a easier formation. I don't know, but I don't think I would expect to see this on an interview. I think it's a little bit on the hard side, but that said, I don't know. Maybe interviews have gotten harder, or Leetcode have gotten because everyone has gotten better at Leetcode. So, but I wouldn't expect. I would not expect to see this kind of dynamic programming problem. I think when I see dynamic programming problem, I expect to see relatively straightforward, like coin change, knapsack, like some stuff with like strain matching and stuff like that, or like edit distance and like subsequent and stuff like that, or like can you do something. But that's what I'm gonna say about that. Okay, cool. I'm gonna spend, I guess, since Poster mentioned it, I'm gonna take a look to see what they're saying in the forums. Maybe I learn. Oh, there's a picture. Oh, that's actually exactly what I did. So I didn't have to draw it. I could have just sent this. Okay, cool. Yeah, I mean, yeah, and then you can convert this to a bottom up, which I support. But in an interview, I not gonna make that jump without being super confident about it. But yeah, I think this is actually, yeah, this is. I mean, I don't know. I guess I'll just leave it up on the screen for a sec or whatever. But this is literally what I was talking about with like this eye here. Oops. I can't really even highlight very well because you can't see my mouse. But on the top left, you could see that the left and what I called in my code, the left and the right is maps to what the I and the J, and K is what I call, well, K is my I, but essentially that's the index that's going out, and then you have these and then you have the yeah. So this is actually essentially what I talk about. So I definitely recommend this explanation if you still have issues with it. I did get to it, so I'm a little proud of myself, I guess. Not because of whatever, but because I've been struggling a lot with these type of problems, these type of dynamic program problems. So it's good to kind of have a win for